All right, welcome to Math 135, section R.2 and R.3. They're a combined lecture note, so don't worry about having to turn in 3 lecture notes for this week. Currently, it is the R.2 and R.3 are on the same lecture note. And again, I haven't gotten my microphone figured out yet, so please pardon the tapping of my pen on the iPad. But let's go ahead and get started. So with section R.2, we're looking at operations with polynomials. And again, as a reminder, polynomials are basically things like these. What it means is poly, think of many. So it's something with many terms. So many, and then nomial is terms. Okay, so we're looking at something that has many terms. And how many terms do our polynomials have at this time? Well, this first polynomial right here has 1, 2, 3 terms. And terms are the things that are kind of separated by a plus or a minus sign. So we have 3 terms in this polynomial. And we also have 3 in the end one. 1, 2, 3. Okay, so let's go ahead and perform the indicated operation. What is the operation? Well, the polynomials are all inside these parentheses, and then we have a plus sign between them. So what are we going to do? We're going to add them. All right, so since it's just a plus sign, none of the signs change. This is a negative 7x cubed plus a 6x squared minus 11x plus 19x cubed minus 11x squared minus 17. So since we're just adding and subtracting, we can only combine the like terms. So the x cubes are a like term, so we have these two are like terms. Then we have the x squares are like terms. And then the x to the 1 power. Oh, there's no other x to the 1 power. And then we have the negative 17, and that is by itself. So the negative 11x and the negative 17 don't have like terms. So we're not going to combine them with anything. So combining the cubed values. We have 19 minus 7. So that's going to be positive 11x cubed. We're done with those, so I'll just lightly cross them out. Now let's take a look at the x squared. So we have 6 minus 11. It's going to be 5. Positive or negative? Oh, well, it's a negative 11, so that's actually going to be a negative 5x squared. And then, oh, we don't have any other x terms, so that one we're just going to write down. Nothing happens to it because there's no other like term. And the same thing happens with the 17. Now notice, I wrote them in descending powers. What does that mean? Well, first I have my x cubed, then x squared, then x to the 1, and then technically x to the 0 power. That would be descending powers. So I'll go ahead and just box my answer, and I'm done. Let me fix that x right there. Okay, gotta make sure you guys can read it. All right, so now let's take a look at the next one. Pretty much a very similar concept, except see the sign on the inside? It is different. This time it's a minus, so we have to be a little careful. We have to make sure to distribute that minus, so we're subtracting everything. So I'm going to go ahead and distribute that minus into the end term. And that's going to be, so the first one will be negative 7x cubed. I'm going to drop the parentheses because there's no minus sign outside of that. Then we have a minus 19x cubed. Now we have a negative times a negative 11, so that'll be a positive 11x squared. Then a negative times another negative, so positive 17. Once again, when we're combining, if we're just adding, we're going to look for like terms. So here's a cube, another cube, a square, and then another square. And then this has power to the x, and again, this time, this one has no x. So we have 2 like terms and 2 non-like terms, or terms that don't have a like term. So we're going to go ahead and combine these two. That's going to be 7 plus 19. That'll be negative 26 x cubed. And then the 6x squared and the 11x squared. Those are both additions, so that's going to be 17x squared. And then minus 11x, and then plus 17. And there we go, we're done. Okay, so that was adding and subtracting. And now, for example C, we're looking at multiplying. So notice, what is the symbol in between the two parentheses? Nothing. So when there's nothing there, you're allowed to assume it's multiplication. So because we have that multiplication going on between, we're going to go ahead and use the distributive property. How many times? Well, let's take a look at the first term. We have 1, 2 different terms. And we're going to distribute each of them however many times it takes to multiply them to each of these terms. So the 6 times this, the 6 times the second term, and the 6 times the third term. Sorry, 6x. So what will we get? I'm going to write this out with more detail than you would need to, but just so you guys see what's going on. Plus the 6x times the x, and then plus the 6x times the -2. So that was the first round. Now we have to multiply out the 5. So 5 times the x squared, then 5 times the x, and then 5 times the -2. I'll go ahead and just write that on the bottom because I'm running out of room. Plus, so we have the 5 times the x squared, plus 5 times the x, plus 5 times the -2. Usually you would continue out writing it over here, but I am kind of running out of room because my pen is a bit big. But just keep that in mind. And also, when you're working, continue to use those equal signs along the side. That is something I'm picky about, so make sure to write those down along the side. All right, so let's multiply things out and see what we get. So the 6x times the x squared, that's going to be 6x cubed, plus 6x times x, 6x squared, plus 6x times the -2, so that'll be -12x, plus the 5 times the x squared, that's going to be 5x squared, plus 5 times x, 5x, and lastly, 5 times the -2, -10. Okay, so now we've gotten into the form we were looking at before, and now, because we have all these plus signs and whatnot in between, now it's just going to be combining like terms. Do we have any other x cubes? No, we don't. Okay, so no other like terms for that. Now let's take a look at the x squareds. We have a 6x squared and, ooh, a 5x squared. How about the x terms? Any like terms? Yep, we have a 5x right there. And lastly, the 10. There is no like term for that one. So since there's no like term for the 6x cubed, we'll just write that down. Then we'll combine the x squareds. 6 plus 5 is going to be 11x squared. Then we have the x values, -12x plus 5, so that's going to be 7x. But a -7x because the 12 is bigger than the 5, so the sign wins out. And then let's see, what do we have left? Oh, just the 10, -10. And we are done. Box our answers. Again, notice my equal signs lined up here and then boxing my answers. That is the way I would expect work to be shown. Again, if you have any questions on how to show your work, just send me an email and I'll be happy to answer that. Okay, so that was R.2. Now let's take a look at R.3. This is factoring. So whenever you're trying to factor, the first thing you want to do is simplify. Again, it's super important. Simplify, and how do you do that? Factor out the greatest common factor. All right, so now what we're going to do is take a look at the different types of factoring. One type is called grouping, and that is usually when you have 4 or more terms. Again, terms are the things that are split up by a plus or a minus sign. So let's take a look at the one we have, for example, 2. How many terms do we have? We have 1, 2, 3, 4 terms. Okay, so that fits our concept for the grouping. We have 4 more terms. How should we group them? Usually, best way to group them is in the order they're given. So we'll group it 2 by 2. So I'm going to go ahead and put my parentheses around this. However, I can't just put parentheses around these and 2. Why? Because that would change the value. I have to remember this minus sign here. If I was to distribute this minus out, that would become a -12, and I can't allow that. So I have to be a little sneaky when I do my grouping. I'm going to change the end sign. Let me write this over here. That's going to be 2x cubed minus 4x squared. Nothing happens with this. But if I want to keep that minus sign from here, and then put parentheses up, I need to change the sign for the 12. That'll be 6x minus 12. And then you could double check to make sure you did that correctly by multiplying in the negative to make sure you get this again, which we would because the negative times the negative 12 would give me the original positive 12. Okay, we're good. So we have set it up for factoring or for grouping. Now what we're going to do is factor out from each group. So looking at the first two terms, what do they have in common? Well, they're both even numbers, 2 and 4, and then they both have at least an x squared. So let's go ahead and factor that out. Alrighty, so we factored out that greatest common factor. Now I'm going to go ahead and bring down that negative sign. Let's focus on the n term. What do they have in common? Well, this has an x, the 6x, but the 12 doesn't, so we can't factor out an x. However, 6 and 12 are both even. We can factor out a 6. So we'll factor out a 6, and what's left over? X minus 2. Okay, so we have factored, we've grouped them, now we factored them. Now we're going to take a look at these two different terms and try to determine, do they hold a common factor? They do. Their common factor is x minus 2. A little tricky, huh? But it's kind of neat. Okay, so let's go ahead and factor that out. X minus 2. And then what's left over? Well, what's left over when I factor those out is the 2x squared and then the negative 6. So we're left with the 2x squared minus the 6. And then let's see. Can we factor this out? Oh, I probably should have done that at the very beginning. I could have factored a 2 out of here. Should have done that. That was said to be my first step. Mistakes happen. Okay, so don't worry. We can still fix it. What do they share in common here? They're both even, so we can factor out a 2. So we'll take out a 2 from those guys, and we're left with x squared minus 3. I'll rewrite that so the 2 is in front, just so it looks a little better. And we are done. Again, if you don't remember to factor out in the beginning, you'll have to do it at some other point. So it really is better to factor it out in the beginning. I did forget, which made it a little harder. But it worked out in the end. All right, so let's take a look at factoring trinomials. There are different methods for how to factor. I'll tell you my method. If you were taught a different method, that's completely fine. There are, again, multiple different ones, but I'll teach you the one that I know. So when trying to factor a trinomial, we want to create two factors with binomials inside of them. Bi meaning 2. So I'm going to take a look at the signs of this problem first. It'll tell me what to do. I want to be able to subtract to get a positive 2x. Okay, so subtract to get a positive 2x. How do I find that out? Well, let's do some side work. I'm going to do some scratch work. I'll label it scratch work so that it doesn't get graded. Again, if you're going to do that on an exam, for the final exam, make sure to write scratch, and then I will not grade the scratch work. Okay, so let's see. We're going to factor the end term. We're not going to factor the first term because that's already a 1. So factoring the end term, what does 3 factor into? Well, 3 just factors into 1 times 3. Those are all we have to work with. So what I'm going to ask myself is, can I subtract these two terms to somehow get a positive 2? The answer is yes. I'll just do the 1. Oh, sorry, take that back. I'll just do the 3 minus the 1, because remember, I want a positive 2. If I wanted a negative 2, I would have done the 1 minus the 3. So you want a 3 minus the 1. So what we're going to go do is write x, and then we have a positive 3 plus 3, and then x minus 1 minus the 1. And there we go. We are done. We have factored. How do we know if we have factored correctly? We could go ahead and just check. Let me just write that in a different color. Check. And multiply it out. So again, this would be the final answer if we were factoring, but we want to check it to see if we're right, which you don't have to do. It's just a good way to double check. So we'll go ahead. X times x is going to be x squared. X times -1, -1. And then we would do the 3 times the x, that's going to be positive 3x, and then the 3 times the -1, -3. Oh, that should have been a -1x. Okay. So then, adding up the like terms of these two, we'll get x squared plus 2x minus 3. And is that what we originally had? It is. So we know we factored correctly. Again, if you're checking your work, please write out that you're checking it. And if you're doing scratch work, write out that you're scratching it. Or that you're scratch working it. Okay, so let's take a look at B. Now, B is different. What is the main difference I see? The big main difference, which is going to make it a little harder, is that we have a 4 in front of our x squared. Before, we just had a positive 1, which made it easier because we only had to focus on the end term factoring. But now, because we have a 4 in front of that x squared, we have to focus on factoring the 4 and the 6. Again, though, let's figure out what the question is for this trinomial. It's asking us, how can we subtract to get a positive 10? We'll be able to subtract to get a positive 10. So once again, let's go ahead and work on a scratch work. But this time we have to factor both the 4 and the 6. So factors of 4 are going to be 1 times 4 and 2 times 2. Factors of 6 are going to be 1 times 6 and 2 times 3. Now, we have to figure out if we can multiply these terms around and then add their products and get a 10. So let's see, I'm just going to pick the 1 times 4 and the 1 times 6. You have to pick one term from each to test with. So let's do the testing. 2 ways to test: crossway, or the 4 times the 6 and the 1 times the 1. Let's do the first one. 4 times 6 is going to be 24. 1 times 1 is going to be 1. Can we subtract these to get 10? No, that's going to be 23 or something else. So that doesn't work. Remember, we're trying to get a 10. So let's do the yellow version. 1 times 6 and 1 times 4. Can we subtract these to get a 10? No, we can't. We'd either get a 2 or a -2. That doesn't work. Okay. So those pairs didn't work, but let's go ahead and we'll try a different pair. Again, remember, our goal is to get a positive 10. So let's try the 2 times 2 and the 2 times 3. You could have tried the 1 times 4 and the 2 times 3, but let's just try this one out. So we'll go ahead and do the first testing, which is around. So 2 times 3 is 6, and 2 times 2 is 4. Can we subtract those to get a 10? No, we could add them, but that's not what we're trying to find. We're trying to subtract them. That doesn't work. Let's do it the other way. 2 times 2 is 4. 2 times 3 is 6. Again, that did not work. Okay, so that pair didn't work. Let's try another pair. What have we not tried? Which combination? Let's try the 1 times 4 and the 2 times 3. We haven't tried that yet. So we'll do 1 times 4 and the 2 times the 3. Do the outward testing first. 4 times 3 is going to be 12. 1 times 2 is going to be 2. Can we subtract to get 10? Ooh, we can. If we did a positive 2 and a negative 12, oh no, that would be a negative 10. If we did a positive 12 and a negative 2, would we get a positive 10? We would. Okay, so negative 2, positive 12, that would give me a positive 10. Okay, we have found the pairs to factor with. So once again, we're going to set up our binomials, but real quick, which numbers had the x with them? It was these ones. So this should be a 1x and a 4x. So the 1x, it doesn't matter exactly where you place them. This first part is up to you, the 1x and the 4x. Now, the next part matters. So the inner term comes from when you FOIL, which is what we did down here. The inner terms comes from when you multiply the outer and the inner products. So the outer and the inner products. the outer product, the x, got multiplied to the positive, oh no, the negative 2. So we'll go ahead and put down the negative 2. And then the 4 got multiplied to the 3. So the 4 got multiplied to the 3. What kind of a 3 was it? Well, we wanted a positive 12. It was a positive 3. Again, you could check by doing FOIL and multiplying it out to see if you have the correct binomial. For now, I'll let you do that on the side if you want, and if you run into trouble with that, just send me an email and I'd be glad to help. So you could check if you wanted to. Again, if you are checking, please write out check, and if you're doing scratch work, please write out scratch. But to let your reader know what your final answer is, we'll go ahead and box our final answer. Now, let's take a look at these special factoring formulas. Okay, so perfect square trinomials are when the first term and the last term are perfect squares, which would be like x squared, or 4 is a perfect square because it's 2 times 2, and so on. Those are factoring methods. Then we have difference of squares, which is when the first term is squared, second term is squared, minus sign, and it's a binomial. Again, so far we're assuming this is review, so if some of these things seem very foreign to you, just send me an email and I'll send you some practice work, or we can discuss it in an office hour. Again, assuming that you have seen these before. But if you need a refresher, just let me know. And that would factor into the difference of squares, where same first term, same last term, just the signs are different. And then the difference on sum of cubes, and these are the very long formulas for that. So let's take a look at our examples. So the first one, I would not use the perfect square trinomials. Why? Because it's a binomial. There are only 2 terms. So it's either the difference of squares or the difference of cubes. How do I know it's just the difference? Because there's a minus sign in it. So which one is it? And you may be going, aha, there are some cubes here. So yes, we're going to be doing the cubes. And which formula are we going to use? This one right here, the difference of cubes. So let's go ahead and set this up so that they each look like a cube first. Oh wait, I run into a problem. 2 is not a perfect cube. What can I do? Well, remember, we're actually supposed to factor this first. So can we factor out something from the 16 and the 2? We can factor out a 2. And then we are left with 2 times 8x cubed minus y cubed. Ooh, and now that looks like a perfect cube. So you have 2, and then, can I rewrite 8x cubed as something cubed? Yes, I can, 2x. And then minus, and we have the y cubed. So if I'm to look at my formula, the item that stands for the x is going to be the 2x, and the item that stands for the y is going to be, well, just the y. So that part doesn't really change in the formula. So let's work on the first part of factoring. We're just going to do the x times the y. So that's going to be 2x minus the y, and then let's work on the next part. My x term, again, remember, is actually 2x, so be careful there. 2x and squared, plus my x value times my y value, plus my y value squared, so y squared. And then we're done. That is our term. So the last thing you might want to do is square that out. So that's going to be 2 times 2x minus y times the, 4, x squared plus 2xy plus y squared. Again, this was basically just plopping items into a formula. So that's the main difficulty part, is remembering what the x is and then remembering what the y's are. Okay, so now let's take a look at the next one, part B. First off, again, what we should always do is factor. See if we can factor out the greatest common factor. So in the 2x to the 5th power minus 32x, it is a binomial, so I know it's going to be difference of squares or difference and sum of cubes. But currently I have a 5 power, or to the 5th power, and a 1 power. So I'm going to try factor out a greatest common factor first. The 2 and the 32 are even, so I'll factor out a 2. And then they both share an x, so I'll factor out 1x. And what am I left with? I'm left with x to the 4th minus 16. Ooh. Okay, so this binomial on the end is actually a difference of squares. Because x to the 4th is just x squared. And 16 is 4 squared. So let's go ahead and write that out. It'll be 2x times x squared squared minus 4 squared. Factoring that out using the formula, that will be x squared minus 4 times x squared plus 4. Now you might be tempted to say we're done. However, be careful. Look at this binomial right here. That one is also a difference of squares. So we have to factor that too. So that one will turn out to be x minus 2 times x plus 2. Then we'll bring down this one, x squared plus 4. How come we can't factor that one? Well, we only have a difference of squares. We do not have sum of squares to factor. So we cannot factor that end term. This can't be factored. However, when we have that minus sign and they're both perfect squares, then we can factor them into a difference of squares. And then we're done. That is the factored form. Again, a thing to note about the work that I expect to be shown, equal signs should be lined up. And then box your answer. Ooh, naughty, I didn't box my answer. Okay, as a reminder, please box your answer. Well, it should be a better box than that, but that'll do for now. Okay. The last thing we're going to do is factoring by substitution. Okay, factor completely. Well, factoring by substitution, it basically is what its name says. You're going to substitute something in, and we do this to try and make the problem easier. So, how do we usually do it? Well, we're going to pick, usually we use a u, other people use different things. We're going to pick the variable u to factor into our equation to make it look simpler. And right now, if you were to look at part A, what makes it confusing? Well, we got these x squareds going on. Can we find a way to take them out? Well, we can, because they're both an x squared, and one of them is a square of the other. So let's go ahead and say, let u equal x minus 2. So when we do that, and we factor it out, when we substitute it out, this is 4 times, and we're going to swap out the x minus 2 for u. And remember, it was squared, so u squared, plus 12 times, substituting that out for a u plus 9. Aha, and now does that look simpler? It does. This is a regular trinomial that we know how to factor. So we'll go ahead, factor that. Let's see, what is the question of this? How do you add to get a positive 12? And we have to look at the factors from 4 and 9. So here's some scratch work. Factors of 4 are 1 times 4 and 2 times 2. What are factors of 9? 1 times 9 and 3 times 3. We want to add to get 12. So I'm going to go ahead and test. I'll pick the 2 times 2 and the 3 times 3. That's going to be 6, and that's going to be 6 again. Okay, again, I tested outside. Can we add 6 plus 6 to get 12? We can. Awesome. Okay, we figured it out. And the 2 were the u values, because the 4 came from the u. Once again, I place my u values first. 2u, 2u, and what did they get multiplied to? Well, it actually doesn't really matter. It's the same thing. Positive 3, positive 3. Again, you could double check to make sure that's true with checking. Now, are we done? Can we box our answer? The answer is no. We were asked to factor this. We need to remember to resubstitute that back in for the u values. So I'm going to go ahead and erase my scratch work and testing to make some space. And let's go ahead and substitute those back inside. So we're going to re-swap the u for the x minus 2. And again, feel free to pause this video at any time if you need to try out the problems by yourself. Always a good way to just test your understanding. Okay, and lastly, I'm going to simplify this by multiplying out that 2. So it's going to be 2x minus 4 plus 3 times 2x minus 4 again plus 3. Adding like terms. The only like terms we have inside of each one are the numbers. We can't add through the parentheses, we can only add what's inside. Okay, and we are done. Go ahead, box your answers. Again, make sure your equal signs are in a nice line. We're almost done, down to the last sample. So let's take a look. What's weird about this problem? Well, instead of a square and a no square, we have a 6 and a 3. But we can go ahead and do some substitution to make it look simpler. So I'm going to use u again, let u equal the smaller one, which is going to be x cubed. What does that mean? Well, then that means that u squared is going to be x to the 6. Real quick, here's a reminder on how that works. X cubed, if I was to square that, what we do is we multiply the exponents and we would get x to the 6th power. Just a reminder on how exponents work. Okay, so let's go ahead and substitute that in and see what we get. First, I'm going to actually rewrite the trinomial so you can see the cubed in both places. Just waiting for my pen to stop lagging. Okay, there we go. That's going to be x cubed squared plus 17 times x cubed plus 66. Now we're going to go ahead, substitute the x cubed for the u, and we have u squared plus 17u plus 66. Okay, so you have a trinomial with a positive 1 for the u. So this is the easier trinomial to factor. So we just have to focus on the 66. And what is the question being asked? What can we add to get a positive 17? So some scratch work. What are factors of 66? Well, the biggest obvious one to me is 11 times 6. Can we add 11 times 6 to get a positive 17? We can. That's going to be 11 plus 6 is 17. All right. So again, that was easier because we only have a 1 in front of the u squared term. All right, so factoring it, we'll have u plus, and what did we factor it into? We had 6 and 11. So u plus 11 and u plus 6. Again, you could use FOIL to multiply that out to see if you got the original. But let's see. Ooh, we have to be careful. Remember, our original actually had an x, and right now we're working with a u. So to get our final answer, we have to remember to swap out that u for an x cubed. So that's going to be x cubed plus 11 times x cubed plus 6. Lastly, we have to be careful. We have x cubed going on. We have to make sure that none of these are a difference or sum of cubes. But looking at the 11 and 6, those are not perfect cubes, so we are done. And that is our factored answer. Alrighty, that is it for this video. If you have any questions, please feel free to email me or sign up for an office hour and we can discuss things.